combining section 2.6, combining functions. Okay. So we have f of x and g of x are functions, and given two functions, we can create a third function by adding the two functions, subtracting the two functions, multiplying the two functions, and by dividing the two functions. Okay? So given two functions, we can create a third function by performing the mathematical operations of addition, subtraction, multiplication, and division. Okay? So in example 1, we're given two functions. F of x is equal to 1 over x plus 3, and g of x is equal to x over the square root of x plus 4. Okay. Now, when we create the new function, adding, subtracting, multiplying, or dividing these functions, we got to know what the domain is of the new function, right? And to know what the domain of the new function is, we got to know the domain of f and g. So the domain for f of x, all real numbers, except for x equals minus 3, right? The only place where f of x, the function f, is undefined is at x equals minus 3. This is exam, right? Exam 2 material coming up, right, from section 2.1. But you should write set x plus 3 not equal to 0, and solve, you get x can't equal negative 3. Okay. Over here in g of x, we got a square root denominator, right? And so in this domain, what's under the square root, we normally write what's under the square root has to be greater than or equal to 0. Okay? Because you can't take the square root of a negative number and get a real number. You get an imaginary number. Okay? Well, if x plus 4 equals 0, though, we'll have square root of 0 is 0, and you can't divide by 0, right? Division by 0 is undefined. So we have to have x plus 4 strictly greater than 0, or x is greater than negative 4. Okay. X has to be strictly greater than negative 4. Can't equal negative 4, the denominator equals 0. You can't divide by 0. Okay. All right. So the first new function we're going to create is f plus g of x. So this is the name of the new function. F is the name of this function. G is the name of this function. The name of our new function is f plus g. And how we find that function algebraic form, we just add f of x and g of x together. Well, f of x is 1 over x plus 3. And g of x is x over the square root of x plus 4. Now, you could write these under a common denominator, right? Common denominator is x plus 3 times the square root of x plus 4. But I'm just going to leave it as is. Okay. All right. Now, what's the domain of these two functions, or this new function? Well, it's all the values of x. Okay. Maybe I will simplify this. I've changed my mind. Okay. So, common denominator, right, is x plus 3 times the square root of x plus 4. So we got to multiply top and bottom of this first quotient by square root of x plus 4. We have square root of x plus 4 over x plus 3 times times the square root of x plus 4. And then we gotta multiply top and bottom of this quotient by x plus 3, and you have plus x times x plus 3. And so that's what you get when you combine the two quotients together, okay, under a common denominator. And now you can see the domain of f plus g, right, are all the values of x that don't make the denominator equal to 0, or make this square root of x plus 4 a complex number, right, imaginary number. So the domain for f plus g of x is all the values of x in both the domain of f of x and the domain of g of x. Actually, you got to take the intersection of these two domains, okay, to get the domain of f plus g of x. So let's graph the domain for f plus g of x. Okay? And the domain in inequality notation for f plus g of x is the intersection of these two. X can't equal -3, and notice I'm using the word and but not or, okay? And x has to be greater than -4. So I get the intersection of these two domains. Okay? And so to graph this, here's the real number line for the variable x. And so here's like -5, -4, -3, -2, -1, 0, 1, 2. Okay. First, it might be easy to graph x greater than -4, right? So x greater than -4, you put an open circle on the -4, and then you shade everything to the right. That's x greater than -4. And x can't equal -3. So x can't equal -3. Remove the shaded area over -3 and put an open circle. Okay. So we have an open circle on -4, an open circle on -3, and then we shade it in between -4 and -3, and then we shade everything to the right of -3. So that's the graph of the domain of this function f plus g of x. Okay. So in interval notation, the domain is all real numbers greater than -4 and less than -3. So we write that as parentheses, -4, comma, -3 parentheses. And then we join to that all real numbers greater than -3. The union, parentheses, -3 to infinity. That is the domain in interval notation. Okay. For the function f plus g of x. Okay. Take the intersection of the domains of f of x and g of x to get the domain of f plus g of x. Okay. Any questions on that? All right. So in the next two, f minus g of x and f times g of x, they will have the same domain. So the next two cases will have the same domain. So next we want to find the new function f minus g of x. And to find f minus g of x, we subtract g of x from f of x. And so when we do that, we have 1 over x plus 3 minus x over the square root of x plus 4. And to write that over a common denominator, you gotta multiply this first quotient top and bottom by square root of x plus 4, and multiply this second quotient top and bottom by x plus 3, and you get square root of x plus 4 minus x times x plus 3 over x plus 3 times the square root of x plus 4. And the domain is the same. That's f plus g. Minus 4 to minus 3, union minus 3 to infinity. Any questions on that? Next, we have the new function f times g of x. Right? That's a product, f times g. And that new function is found by multiplying f of x by g of x. So f of x is 1 over x plus 3. G of x is x over the square root of x plus 4. And so, you know, when you multiply two quotients, you just multiply straight across. 1 times x is x. Then we have x plus 3 times the square root of x plus 4. And the domain for f times g of x is the same as f plus g of x and f minus g of x. Minus 4 to minus 3, union minus 3 to infinity. All right, so any questions on fg of x? Now, f over g of x is a little trickier, because now you're doing division. Okay. And so this is equal to f of x over g of x. F of x is 1 over x plus 3. And g of x is x over the square root of x plus 4. Well, now you're dividing two quotients. So you know when you do division of two quotients, you keep the top fraction. This write it out. So we have 1 over x plus 3. We know fraction bars are like division symbols. So we have 1 over x plus 3 divided by x over the square root of x plus 4. Well, keep, switch, flip, right? Keep, switch, flip. So we keep the first fraction. We change division to multiplication, and then we flip the second fraction. And now you can multiply straight across, and we have square root of x plus 4 over x times x plus 3. I changed the order of multiplication from x plus 3 times x to x times x plus 3. Okay? All right. So the domain of this function, okay, is the combined, right? The combined domain, the intersection of the domains of f and g, which we calculated already. Okay. Plus, we got to remove those values of x that make g of x equal to 0, because you can't divide by 0. Right? G of x equals 0, you divide by 0. Well, there's only one place where g of x is equal to 0. Right? There's only one number you can put it for x up here that makes g of x equal to 0, and that's 0. Right? G of 0 is equal to 0 over 0 plus 4, square root of 0 plus 4, which is 0 over 2, which is equal to 0. Okay. So we got to remove 0 from the domains from the previous 3 set parts, right? We had minus 4 to minus 3 union minus 3 to infinity, right? That was the domain for f plus g, f minus g, and f times g. But now we got to remove the number 0 from this. Okay. And so let me regraph that domain. Right. Here's minus 4. Here's minus 3. Minus 2, minus 1, 0. We had open circle minus 4, open circle minus 3, and then we shaded everything to the right. We gotta make this a little bigger. We gotta add plus 1. And then we shaded everything to the right. Well, in f over g of x, this new function, f over g of x can't equal 0. Because if x equals 0, we have g of 0 is equal to 0, and you can't divide by 0. Right? Division by 0 is undefined. So x can't equal 0 in this new function. Okay. So the domain is x can't equal minus 3, and x cannot equal 0, and x is greater than negative 4. Right? So we got to put an open circle on 0, just like we did with minus 3. So this is the graph of the domain where x is greater than negative 4, and x can equal negative 3, and x can equal 0. And so in interval notation, the domain is minus 4 to minus 3, union minus 3 to 0, union 0 to infinity. Okay. So we remove the number 0 from the domain of the previous 3 combined functions. Okay. Because you can't divide by 0. Because that x equals 0, g of 0 is equal to 0, you can't divide by 0. Okay. Any questions on that? All right. So it's 9:35 already. We have a quiz, right? Today is Wednesday, right? We've only got 15 minutes left in this class, right? All right, let's take the quiz.